Hi there, and welcome to this lesson on Pure Mathematics 1. We're on Chapter 2, Quadratics, and we're looking at solving quadratic equations. In this lesson, we'll just be looking at how you solve quadratic equations by factorizing. A quadratic equation is any equation that can be written in the form ax squared plus bx plus c equals 0, and we need to get used to this sort of set language. The way you would read that is where a, b, and c are real numbers, that just means normal numbers, and a is not equal to 0. If a was 0, you wouldn't have any x squareds, you wouldn't have a quadratic. Quadratic equations can have 1, 2, or no real solutions. We looked at factorizing in 1.3. The only difference is that now we will have an equation to solve. So 4 questions for you to have a go at. Pause the video and come back to me when you're ready. Okay, let's have a look at these. So the first question, quite easy to slip up on this one. All you have to see is that x is common to both terms. So x can go outside the brackets, and we have x plus 4 inside the brackets. Then an important piece of logic, which we meet a lot when we're solving equations. If you have two things, a and b, and you multiply them together and get 0 for the answer, either a will equal 0 or b will equal 0. Otherwise, it's impossible to get 0 for the answer. One of them must be equal to 0. So if you have x times x plus 4 and the answer is 0, either x equals 0 or x plus 4 equals 0, but one of them must do. So the first case is that x equals 0, which takes us straight to the solution. X is 0. The other possibility is x plus 4 equals 0, which we have to solve, and that gives us x equals minus 4. And that's it. The two solutions, or roots, those two words mean exactly the same thing, are x equals 0 and x equals minus 4. Second question, x squared plus 8x plus 12 equals 0. Well, there's a standard method for factorizing this type of quadratic, which we looked at in Chapter 1. I'll quickly use it again now. To factorize the general quadratic, ax squared plus bx plus c, in our case, we're looking at 1x squared plus 8x plus 12 equals 0. We have to find two numbers that multiply to give AC, which add to give B. AC is 1 times 12, which is 12. B is 8. So we're looking for two numbers that multiply to give 12 and add to give 8. The two numbers that work in this case are 2 and 6. 2 and 6, 2 times 6 is 12, 2 plus 6 is 8. They work. We then split the x term up, the middle term, into two parts, using these two numbers with their plus or minus signs. In this case, both are plus. So x squared plus 8x plus 12 becomes x squared, and the 8x splits up into plus 2x plus 6x. Doesn't matter which order you write these down in, it'll still work whichever way you choose. You then factorize each pair in the normal way. So the first pair is x squared plus 2x, the second pair is 6x plus 12. Factorizing the first pair, you get x into x plus 2. Factorizing the second pair, you get 6 into x plus 2. Now, frequently there's more than one way to factorize these. Be careful, you need to get exactly the same thing in the brackets. In this case, I've got x plus 2 in both brackets. Make sure that's the case, otherwise it doesn't work. Because we're now going to factorize again by taking out the common pair, which is x plus 2. So taking out x plus 2, we have x from the first term and 6 from the second term. So going back to the question, x squared plus 8x plus 12 equals 0. We factorize this into x plus 2 times x plus 6 equals 0. And then there are two possibilities, either x plus 2 equals 0, which gives us x equals minus 2, or x plus 6 equals 0, which gives us x equals minus 6. That's it. Those are the two solutions, x equals minus 2 and x equals minus 6. Third question is similar but more difficult because the numbers are more difficult. Using the same method as before, we're looking for two numbers that multiply to give AC and add to give B. A is 6, B is minus 5, be careful with the minus, and B is plus 13. So two numbers that multiply to give minus 30 and add to give 13. 15 and minus 2 work. If we do 15 times by minus 2, we get minus 30. We do 15 add minus 2, we get 13. We then split the x term into two parts using these two numbers, including the plus minus signs. So it'll be plus 15 and minus 2. 6x squared plus 13x minus 5 becomes 6x squared plus the 15x minus the 2x minus 5. We then factorize each pair in the normal way. 6x squared plus 15x becomes 3x into 2x plus 5. This second pair confuses a lot of people. You can take out 1. In fact, you really want to take out minus 1. If you take out minus 1, that'll give you 2x plus 5 inside the brackets. We need to have the same thing in both brackets. Then we factorize again, taking out the common pair, which is 2x plus 5. And that leaves us 3x from the first pair and minus 1 from the second pair. Okay, going back to the question. We want to solve this equation. We factorize the quadratic into 3x minus 1 times 2x plus 5 equals 0. Either 3x minus 1 equals 0, in which case 3x equals 1 and x equals a third, or 2x plus 5 equals 0, and 2x equals minus 5, and x equals minus 5 over 2. Those are the two solutions. X equals a third, and x equals minus 5 over 2. The fourth question, x squared minus 4x plus 7 equals 2x minus 2. We need to tidy it up so it looks like a normal quadratic. So collect everything on the left-hand side. That'll give us x squared minus 6x plus 9 equals 0. We then factorize that in the normal way. I'll go straight to the answer this time. That's x minus 3 times x minus 3 equals 0. With factorizing quadratics, the better you get at them, the more you should be able to just go straight to the answer without using the standard method. But the standard method's always there in case you need it. Now this has one repeated solution where x minus 3 equals 0, which gives us x equals 3. But that happens for both brackets. The way you would normally write this down is the equation has one repeated solution, x equals 3. Now keep an eye out for questions which can quickly be solved just by square rooting an expression. There are two examples here for you to have a go at. Don't do them the same way we did those last ones, but try and find a quicker way of doing them. I'll let you try by yourselves first, pause the video, then come back to me. Okay, let's look at the best way to do these. So the first question, 3x minus 7 squared equals 81. Well, all we have to do is square root both sides. So it's set up as a perfect square on this side and something you can square root on the right-hand side. Square root of the left-hand side is 3x minus 7. The square root of the right-hand side is either plus 9 or minus 9. We need both possibilities. First of all, if 3x minus 7 is equal to plus 9, then we solve that equation. That'll give us 3x is 9 plus 7. 3x is 16 when we add those together, divided by 3. The other possibility is that 3x minus 7 equals minus 9. We now solve that. So 3x is minus 9 plus 7. Minus 9 plus 7 is minus 2. So moving the 3 across will give us x equals minus 2/3. And that's it. Those are the two solutions, x equals 16 over 3 and x equals minus 2 over 3. The second question, x minus 5 squared equals 13. We use the same method. If we square root the left-hand side, we get x minus 5. If we square root the right-hand side, well, we can't square root 13, but we just leave it as a surd, as the root of 13, making note that it could be plus, it could be minus. Then we do the same as before. So either x minus 5 is equal to plus root 13. We solve that by moving the minus 5 to the other side. You could write root 13 plus 5, but it's slightly more normal to write x equals 5 plus root 13 the other way around. The other possibility is that x minus 5 equals minus root 13. Again, moving the minus 5 across to the other side, the slightly more normal way of writing the answer would be that x is equal to 5 minus root 13. So the equation has got two solutions, x equals 5 plus root 13 and x equals 5 minus root 13. That gets us to the end of today's lesson. If you have the textbook, then turn to page 20 and have a go at exercise 2A. But that is the end of the lesson for today. So cheerio.